Let's solve a regular expression matching problem, and this is a hard problem. We'll see the companies that ask this question, and then we'll understand the problem again and we'll try to solve. So these are the companies. They asked this question. We'll understand this problem and then we'll try the logic. So regular expression matching, here there is a string and there is a pattern. So pattern is A. So if there is just a letter here, then we can check this letter, first letter, and then we can check the first letter that match. But in the second letter A and there is nothing here, so return false. And if you see this other example, if there is a star here, so A, the first character match, and for the second character A, and star means like 0 or 1, so 0 or 1, so that means it match here. There is a so this A repeated here, so that can match. So that's the pattern. And in the case of dot, so dot can match with any character, so A, so that here can be the first character can be anything. So that's what the dot says. And for the B, there is a star, so any character can match here. So that's the problem we need to solve. Let's see any other example, new example. So all these 3 examples given here. So I'm going to use here dynamic programming, and I'll use the recursion. So, and with the help of recursion, it's very easy to understand. So let's try that. So the way I'm going to solve is, first of all, for this string, I will fix an index and I will say that I index, and for the pattern there is a j index. So I will start checking with this item AI, and I will or I can say that SI and then PI. I will check that, and if both are same, I can move. I can check other item, there is no other item, then it will fail here. If there is dot here, like if you say, or in this example, if there is a dot at the end, then I can check with A that match. I can check other character A, and I can check if there is a here also, or dot, that's also true, that is match. So if I find in a second character is A, that's also good, or second character is dot, that's also good, because both match. In that case, I can return true if there is another A here. So I can do that. There is a complexity for star, and when we see the star, what we do. So that's the main difficult logic here. So here I'll see A and first character A, so J, so AI and AJ, so A and A match, that's good. So I can say there is a match, and also I can also check if the next character is a star or not. So if I find the next character is star, first I must match the first character, so first AA is good, and for the second character I will check the pattern first. In the second character in a pattern, if there is a star, then in that case I will use the 2 different route for the recursion, path 1, or I can say path 1 or path 2, or route 1 or route 2. I can say I need 2 recursion. And why I need the 2 recursion, if there is a star here, then one route is I can increase this I, and I will take A, and again I can check, okay, there is a star that match. I can increase this I and go and proceed from there. And when at the end, like if I see I is also the equal to length of S, or J also equal to length of P, then in that case, that's the base condition, exit condition, I can exit. So that's the one route I can check. But there is a possibility also in a pattern, there is a star, and suppose there can be B also. So that means, in that case, A star and B. So that means the first A match, second A with a star match, and at the end there should be B. So in that case, that is the second route I want to go. So in that case, what I do, I can fix the I. For the second route, I can fix the I here, A, and then I can jump to the another value, that's I plus 2 or J plus 2, because I can check after a star there is anything here or not. So that's the two route I'm going to use here. So we'll see the code. I'm going to do the same thing, and again we'll understand here. So the first base condition we can check when we use this, and then when I greater than this length or equal to, or J greater than equal to this length, then we can return true. So that means we found and there is a match, like there is a match of this S and P. So that's the base condition I'm going to use, but for that I need one helper function. So let me copy this and I'll put it here. That's the func, and I can say this is the helper, and I need the I and J index, that's the int, and I can call this function here at the top and return this S and P and the 0 and 0. So I and J, I just want to start with 0 and 0. And the base condition I can say, if I greater than equal to length of S and J greater than equal to length of P pattern, then that's a return true. That means we found or there is exact match, so return true. In the case, happens like, the I is somewhere and J went outside of this, or it reached to the length of this P, and I is before that, then that is, in that condition we want to return false. So I need to check that condition also. If J greater than equal to length of pattern, then return false. So that's the base condition. Now we can add the logic, the real logic here. So I can say, if this character, first one, like if I0 is equal to J PJ pattern and J, that means this first and this one, if match, or PJ is equal to dot. So if the dot, that also we can consider match. If there is a here, that's also good also. Or if the both character match, that also good. Otherwise, if I take the first character, then if there is a dot also, that's fine. That means also we can say that we found the match. So if this is the condition, and in this case also we need to check this, we are using the I, so we need to make sure I is less than length of S. So if I less than length of S, and so I need to wrap this in one bracket. If this is the condition, I can say match. So match is one variable. Initially it's a so false, but if this is the condition, I can say there's a match found. So match is equal to true. I can continue with other logic here, but that will be a little bit complex when I deal with a star. So that's why just I'm going to maintain with a variable. And here I can check. I could have put this logic here, but you'll understand that why I'm doing later. But I can say if match exactly. So we got this true, and that's happened if the first character is a matching. So if it match, then I will move the I and I'll move J and call this is helper again. Yes, so I can say return is helper S and P and I plus 1, and I can say J plus 1. So this I can do here. At the end, I can say return false. So till here, this is a simple logic. I could have put this thing here, but I have not put, because I need to deal with one corner case. I will tell you later. But the complex case comes when there is a star. So here I'm checking if j less than length of p, and not a j, but I can say j plus 1, because I want to so like in this example I will be here a and a, I will check that okay, that's match, and from here also, so see this condition I and j will be same, 0 0, so a and a will match, so match true. And from here I can check if the in a pattern in the next character is a star or not. So that's why I'm saying j plus 1. So j plus 1 length less than length p, and then I can check if j plus 1 is equal to a star, and this should be in single quote. Okay, so if the next character is a star, then I need a to route. So to route, so I want to go if it is a star, then I want to continue recursion with the next pattern if there is another item here, next pattern. And also I can move the I, second route I can move the I, but fix the pattern at the same place. So to route I want to continue with this. So let me do that. So if this is the condition, then what I do, I will call this function. I can say this is the path 1. Path 1 is equal to this function where I want to fix the I, but j I want to continue with the next character. So my pattern moves here. If this is a true, my pattern moves here, and then again I want to continue with this other item there. So that's why just I added this logic here, path 1, and I can check if path 1 true, then return path 1. So path 1, that's a boolean value. And so that's the one route. And another route is, again I can copy the same thing here, copy and paste, and I can say this is the path 2, and here I want to proceed with next character, but I want to fix the pattern same. So the pattern will be same here, and then I want to take another character and then check with that. So that's how I want to do in this case. If the path true, so path 2, then I can return path 2. So that's the logic, whole logic. Let's run, and then we'll convert this to the dynamic programming later. I will make use of this match also. Let's see the syntax. 23 undefined si is equals pj or pj I less than si equal to pj or. So there is this bracket close at the wrong place. Here I can put this place. Okay, so all this test case passes here, but let me submit and see there is an issue. So it will not pass, see the 8 out of, it failed at 8. So 8 of this 356 test case pass. If there is a the combination of star and this dot, so for that, in that case we need to handle this this also, dot also. So for that I need to check one more condition here, if match, if there is a dot and if there is a match happen, then only you go for the second route. So that's, let me format this code, let me run again and submit. Okay, so this solution got accepted, but if you see the runtime is not good, so in that case we need to use the memoization, and we have already learned how to use the memoization in many other videos. So let's use that, the similar pattern I always use. I create the map for that. So map here I can say make and map, and for this it's a string, and the value I want the boolean, and you can pass this map here, and also map here, map string, and then boolean. And after this, in this place I can form the key here. So key is ij, because in a memoization ij both are the varying, so this value is getting changed, so I can make use of these two values. So empty printf I or %d hyphen %d and ij, that will be my key. And based on this key, I store this value. So instead of returning the path 1, before returning path 1, I will do in a m and the key, and key is equal to path 1. And here also, before returning path 2, I can add this in a m and key path 2. And here also, before returning, I can store this in a variable. So or I can say result, return the result, and I can store this result in key result, and this false also here I can store in key is equal to false. Okay, so that's I store this result in a variable, that's called memoization, and I can check if I find the result in this recursion journey, I can return that value. So I can check if v okay, and I will check in a map that will put the key, and if the value exists, okay, then return v. Let me run. So before that, we need to pass in wherever we call this. So here in, you can pass in here, and also here. It's run now. Okay, submitted. Okay, now see, 7 milliseconds. So yeah, so that's good. So that's here we use the memoization. So this is the whole code here. Okay, so that's the whole code. So that's all for now. Thank you.